Hey guys, Professor Doney back here. We're talking about heat in chapter 14. This is going to be a short video. Hopefully I can do it in one instead of two. A short introduction to chapter 14 in heat. Alright, we finished at 13 talking about temperature. Temperature was the average internal kinetic energy. And what do we talk about heat? Well, heat is a form of energy. Just like we learned in conservation of energy in chapter 6 with potential spring, potential gravity, and kinetic. Heat is a form of energy, and it'll be no surprise that we use capital Q to represent heat. I know, exactly. And heat is defined as the energy transferred, so transferred due to a difference in temperature. Now it goes from one object or body to another. Sorry about my handwriting here. You can check the lecture notes, hopefully a little better there. So heat is the energy that we transfer due to a difference in temperature from one object to another. I can't transfer heat to myself. It goes from one object to another. And the reason it's transferred is because there is a difference in temperature. Now, which direction does heat flow? Heat always goes from the hotter or higher temperature to the colder. So that is the direction of heat flow. Okay? Fluids go from higher pressure to lower pressure. Heat energy will go from the hotter or warmer object to the colder one. Okay? Now, how do we measure this? What units do we use? Well, we typically measure in calories. And a calorie, 1 calorie, that's a small c, is a very small amount of material or energy. So we're going to look at 1,000 small c calories, which we call a k-calorie. K meaning kilo. And we'll make it even easier, 1 big C calorie. And that big C calorie is what you're going to see on food. Alright? You look on the back of a P and M&M's and it says it's 400 and some calories. It's talking about that. Okay, but what does 1 big C calorie equal? 1 big C calorie equals 4186 joules. Okay, remember joules was the unit of energy from chapter 6. Okay, 4186 joules of energy. Okay, so if I ate a M&M's that had, let's say, 500 calories in it, because I looked on the package, the amount of energy stored in that food would be 500 times the 4186, which would give me a pretty large number, I think somewhere around 2 million and change, 21. Alright, if you go through the math there, about 2,100,000 joules of energy. Now, it sounds like a lot. It is. There are a lot of calories in peanut M&Ms, even as good as they are. And typically, the foods that taste better for us do have more calories. Okay, but what can we do with that? Well, let's say I want to work that off. I want to burn that energy off that is in those M&Ms because I ate them, because I don't want it to go into my body and be stored in my body as fat. Okay? What I would need to do is set that amount of energy in the M&Ms to, if I was going to do stair climber, I would set it equal potential gravity. Basically, how high up do I have to climb either on the Stairmaster or climbing actual stairs to burn that off? I would set that 21 or 2,100,000 joules equal to mass gravity height. And if I use myself as 100 kilograms, or if I use someone around 60 kilograms, if you do the math, I think it comes out to about 3,600 meters. And there's about 3 meters per floor, so that's going to be about 1,200 floors.